Hello everybody, my name is Seamus and welcome to chapter 6.1 titled Energy and Metabolism. All over the bodies of organisms just like us, cells go through various types of processes. These processes sometimes require energy and sometimes release it. Chemical reactions just like these that together create and then use the energy are what make up a system's metabolism. Today we're going to be discussing how chemical reactions play a role in energy transfer, and then we're going to be looking at metabolic pathways and looking at the two main types. Cellular respiration is a process that organisms, like ourselves, go through in order to consume sugar, a simple carbohydrate, and then break it down to use the high amount of energy sugar molecules have. If you'll notice from the breakdown of glucose equation in front of you, energy is one of the outputs that comes from it. Glucose and other consumed carbs all start in plants from a process called photosynthesis, a process that converts CO2 into carbs like glucose through light energy. Notice how these equations are the complete opposite of each other. Together, these two can completely change light energy to chemical energy. The process of photosynthesis starts with the plant absorbing light energy from the sun. The light energy is first transferred into chemical energy that will temporarily store itself into ATP and NADPH molecules. ATP and NADPH are both essential energy carrier molecules for all cells to work and can be thought of as energy currency. The plant, under ideal circumstances, will create one glucose molecule from 6 molecules of CO2, carbon dioxide. To do so, 18 molecules of ATP and 12 molecules of NADPH are required. But because NADPH has an equivalence of 3 ATP when it comes to energy, that ends up being around 54 ATP energy equivalent. As you might guess, this is the first step that allows for a much larger process. Almost all life forms on Earth obtain their energy through this, either directly or not. Plants directly get their energy from doing this process themselves and then collecting the energy. Herbivores eat the plants, consuming important molecular bonds high in ATP that has been created through photosynthesis. In cellular respiration, The carnivores then eat them, consuming the nutrients that the herbivores had just eaten themselves. And finally, plants and animals alike are ate by the decomposers, like fungi and worms, who then release the heat back into the world. You can clearly see how this is all just a big transfer of energy, pushed by very small individual chemical reactions, almost as though the world has its own metabolism system. The processes showed earlier of both creating and breaking down glucose are great examples of the two main types of metabolic pathways and how they interact with each other. Anabolic pathways need an energy input in order to synthesize complex molecules from simpler ones. The example use of creating glucose from CO2 is one example, but the textbooks includes more examples of processes like synthesizing large proteins from amino acid building blocks and making DNA strands from nucleic acid blocks. These types of processes are absolutely crucial to the life of organisms and constantly require energy. The process known as photosynthesis and the energy that it creates can also be labeled as a catabolic pathway. A catabolic pathway degrades or breaks down complex molecules into simpler ones. Energy that is stored in molecular bonds released into these pathways and give up ATP. Other energy-rich molecules like fats can be used in the same way sugar has been. Because no energy is involved in a special protein called an enzyme is used to facilitate this process. That's about all for me. Thank you so much.